Okay, difference in our y values for f of x. Between our x is a plus h and where our x is a. Okay, next we're going to label our h. Again, I'm going to draw this out here, but you could just do, well, you know, we could just highlight what's here. And mark this as 4, though. And that is our h. Again, this is a length. And our h, to define it, this is our displacement. Or our distance on the x-axis. Between our values, x is equal to a, and x is equal to a plus h. Oh, what colors have I used? Let's do green. Okay. Next we're doing our formula. Remember, this is our formula for a slope. Okay, and this is our number 5 here. This right here is our secant line. I'm going to go ahead and label that, and this is number 5. Okay. So number 5, to put this in terminology, this is our average rate of change. Or AROC for short, of our f of x on the secant line of a plus h, meaning in between those two values. Okay, for 6 and 7, I need to draw a tangent line. So if you don't have a straight edge, it's okay. Just make it up. It doesn't have to be perfect. Tyler, get out of here with the 6, 7. Okay. Tyler, you didn't see him? Okay. But that's our hypothetical tangent line. And we're using this for 6 and 7. Okay, I know it looks a little chaotic. It's okay though. Okay. So moving on down, So both, well, we'll just start with 6. So this also represents a slope. And to define this is the instantaneous rate of change. Instantaneous. Or the IROC for short, of f of x at our specific point x is equal to a. We also need to note that we're utilizing our tangent line, also known as the slope or the derivative. For f prime of a, so again, if you weren't here yesterday, then you missed this terminology. This is the proper way to write the derivative, and it is the same thing as what we were doing in our first lesson. It's the slope of the tangent line at a specific point on a function. Okay. So now, last page. So, we're going to do this backwards now, and we're going to look at our symbols. So, remember our function that we've been using? Ooh, where can I write this? Is we have our f of a plus h minus f of a divided by h. And we're trying to find what is our original f of x, meaning our actual function here. And what is our value? I wrote a. I should have wrote c, but it's okay. We're solving for what our x value is. So we're solving for the c. The c, I said the x value. The x value of the point that we're utilizing on the function. Because remember, whenever we're solving for the slope of a tangent line, we're using a specific point on that function. So we're solving for the x value that we've been using. Okay? So to do this, you want to see if you can identify where you can find an a plus h or where you can find an f of a. So it might be, this one's pretty simple. So I have a 4 plus h in the square root. So if I look at what my function is, it would be the square root of our x value, because this is our a plus h, this is our a. I can also prove this by looking at our f of a. The square root of 4 is 2, so that also confirms that. Okay, so let's look at b here. Look where your variable is. We have an a plus h, which tells me that my c value, the value that I'm using for x, is pi, because I have pi plus h. To do my function, I'm going to look at my base. My base is e to the cosine of x. Okay. Again, look at your x value, your variable that's been plugged in. Okay, so let's look at c here. On my first one, where it should be a plus h, what do you think is our value for the variable x? 2. Okay, now let's look at our f of x here. Okay, look at our base. What do we think is our function? That's correct. Tan 2 times x. Let's go and put that in parentheses. Okay, D was a funky one. Y'all might remember this. It's okay if you don't. It's from Algebra 2, so it would have been a hot minute ago. Okay, but I didn't want to skip over it or change this question because who knows if you might see it again. Okay, but this is called the quotient property of logarithms, and all it says is that if you have, and it can go backwards and forwards, but if you have like a logarithm, any logarithm, okay, and you are dividing two values, it's equal to those two values, like, subtracted. So, the reason why you need to use this to solve is we're going to write it backwards. So, we have our 1 over h times, this is going to become natural log 6 plus h. And because we're dividing here, we're going to subtract like that. Yes.
What exactly is 7? Like, what is it? Does it mean, like, to what power does e equal the value? Is that what it means?
I don't like the way that you worded that. But yes, it is related to your e. It's a naturalized form of the logarithm e. Okay. I tell you what, I don't know how to fully answer that question right now. So how about I get back to you with that answer to the question? Is a formal definition okay, on that note, if you're asking what ln is, do you want the formal definitions of all of them? Like, for example, E.
Oh, yeah. Isn't it like 2.7 something?
Okay, what about your log base of a number? Do you want a formal definition of that one? Okay. Okay. Okay, cool. But for now, we're just going to work with it. Okay? Shh. Okay, so now we can look at our a plus h and our a here. So what do we think is our value for x? 6. Okay, and what do we think is our function? That's correct. Okay, the last two, E and F, we did our alternative form. This one's way easier to identify because it's labeled for you already. So our value for x is what? 3. Okay? And then our f of x was already written for us again here. So my people who weren't here yesterday, in the alternative form of your derivative, you did your f of x minus your f of a. And so your f of a, you would go ahead and plug in that number. So here we would have plugged in 3. It would have been 3 minus 1 squared. And then you take that number and subtract it. Okay, so let's look over here at f. What's our value for x? -2. Okay, and what's our f of x? What? Yeah, -6. Okay. You know what? I probably have time to look up what the formal definition is. Okay. Okay, my people who weren't here, I don't think I gave you an assignment before you left. Did I give you the assignment for 2.2? No. Okay.
Yes.
Yeah, I gave it to him the day before. Okay. No, I gave them the filled in notes and blank notes. Okay. So like I said, I wanted to do for sure 13 with y'all. Because while I don't think it's difficult by any means, we weren't using this terminology in the notes. Okay? It's okay. Wait, that's 2.1. I don't want to look at that one. Okay. So in order to do 13, we're going to estimate our f prime of x, which is our what? What are we looking for? The slope of the tangent line. That is correct. Okay? And we're going to use each of our values at that point. So we're going to start with point A, which is right here. That is -3, -1. Okay, all I'm going to do is I'm going to take a straight edge. Oh, whoops. That's a crappy straight edge. Don't use this one again. Okay. And I'm going to estimate my tangent line here. I should really get a better ruler. Okay. Okay. So we're going to look at our behavior at this point. This line, is it increasing or decreasing? Or is that what we're calling a relative max or min? Increasing. Okay. We're going to estimate our slope here. So my estimated point I'm going to use right here, this is 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1. Our estimated slope is 9. And then it wants us to write our equation in point slope form. So we have a point, we have our slope, so we're going to do y is equal to, not minus, our value for our slope, which is 9, x minus our x value, that's a -3, so this becomes x plus 3, and then plus y, and we have a -1. So there's our equation for the line. Okay, if we look at our b here, which is at point -2, 3, B and D are the one. Well, is it B or no? It's B and C are the ones I didn't think were fair. Okay. If I look at the behavior of B, my tangent line, would look like this. It would be a horizontal line, which tells me this is about as high as it goes at this point in the function. So we're going to call this a relative maximum. Our slope for horizontal lines is 0. Oh no. Okay, ignore that. This is an equal sign. Okay, and then our equation for this line would be y is equal to 3. Okay, so on C, we're going to estimate this point because it's not perfectly on there. We're going to call it -1/2. And what is that? 1, 2, and 2.5, so 5/2. Okay, same thing on C. If I drew the behavior of that line, or at that point, my tangent line would look like this. which means my estimated slope is 0. Unlike on B, though, this is the lowest that it goes at that current point in the function. So we're going to call this a relative minimum. Okay? And same thing, our slope is 0. So our equation for this line is y is 5/2. Okay, for D, our point is 1, 5. So again, I'm going to take a straight edge and I'm going to draw my tangent line for D. Okay, that's good. Okay. Is this increasing or decreasing? Increasing. Okay, to estimate our slope, I'm going to use this point, and whoever said 2 is right. Okay. So now we have a point, we have our slope, so we're going to write out our equation here. So we have y is equal to our slope, which is 2, times x minus x1, which is 1, so x minus 1, plus our y, which is 5. Okay. We're going to skip E and F together so that I can do 2, 4, and 6 with you.
So we don't have to do E and F?
No. Those 2 are decreasing, but you're doing the same process that you're doing on the A and D. Was it D? Yeah, A and D. Okay. Okay, so just an FYI, these are going to be like your examples on 2.1. We did do it in 2.2, but remember, we've been talking about doing the same process. So there's our equation. We're doing f of x plus h minus f of x divided by h. So we're doing our limit as h approaches 0. Remember, wherever you see that variable, you're going to plug in x plus h, and then you're going to subtract and do your normal f of x. Okay, in this example, you're also going to do it on 7, but remember, you need to get rid of these symbols and be able to have something to cancel out and subtract. So we're going to do 2 minus x plus h plus the square root of 2 minus x, which I don't have room to write. Pretty much we're doing this, but with the plus symbol now, just like what we've been doing. Oh wait, not divided by h. That is probably the worst handwriting I've done in a very long time. That was terrible. Okay, but we're going to multiply these out. So this becomes 2 minus. We're going to go ahead and distribute this negative symbol, so this becomes negative x and negative h. And we're going to go ahead and distribute, because remember, a positive times a negative is a negative, so we're going to go and distribute that. So this is going to be minus 2 plus x. Remember what's in our denominator, because we want to be able to cancel it out. We're going to leave those as is, so it's h times the square root of 2 minus x plus h plus the square root of 2 minus x. I have a positive x and a negative x. Those are going to cancel each other out. I have a negative 2 and a positive 2, and those are going to cancel out. I'm left with a negative h, and these h's can cancel out, and this is going to become negative 1 over 1. So now let's go ahead and write our next line. I have negative 1 over the square root of 2 minus x plus h plus the square root of 2 minus x. Our next step, now that we've eliminated that h we were dividing by, is to go ahead and plug in our 0. So, remember, our formal way to write this now is g prime of x. I have negative 1. If I plugged in my 0 for h, this is the square root of 2 minus x. And then this is also the square root of 2 minus x. So I can combine those, and this is negative 1 over 2 minus x. So now that we have our answer for 2, we're going to take this answer and use it on 4 and then use it on 6. You're going to do that same process on 1, 3, and 5, and even on the next page on 7, you're using the same function to do it. So we're going to find the equation of our tangent line at our point x is negative 7. So the first thing we need to do is find our f of x value or our y value at negative 7. So I'm going to plug in negative 7 into my equation. So I have g of negative 7 is the square root of 2 minus negative 7, or 2 plus 7, which is the square root of 9. So g of negative 7 is 3. So now I have my value for my point, which is negative 7, 3. I'm going to save this for later when we go to write our equation. Our next step is to solve for our slope of our tangent line. We already have our general formula, which is negative 1 over 2 times the square root of 2 minus x. I'm going to plug in my x value now. So g prime of negative 7, I have negative 1 over 2 times 2 minus negative 7. So I have negative 1 over, that is square root of 9, so 6. Negative 1/6 is my slope.
What was the point of plugging it into the original?
To get our point negative 7, 3, because we wanted our y value, because we're going to write our equation for the tangent line, and we need our y value to do that. So now let's write our equation. Y equals, our slope is negative 1/6. We're doing x minus x1, which is negative 7, so this becomes x plus 7, plus our y value, which is 3. So again, we're going to take this equation and we're going to use it on number 6, because on number 6, it's asking us to find the equation of the normal line. If you remember from last lesson, the normal line is perpendicular to the tangent line. So we're going to take the opposite reciprocal of our slope of our tangent line. What's our opposite reciprocal of negative 1, 6? 6. And then we're using the same point, which is negative 7, 3. And all we're going to do is write the equation for the normal line. And it's pretty much the exact same equation, just with the slope changed. Okay, you're doing the same process for 1, 3, and 5. I just wanted to do that one together because it's one of those where you do the funky multiplying.
So is this due Monday or tomorrow?
2 days. So no, it's not due tomorrow. Okay. Okay. And then oh good, we don't have to do this together because I already did them for you. I did model a couple, so I modeled 14 and 15 and 20 for you. The notes that I wrote on the side here, all it says is see notes 2.1, example number 6, or 2.2, example number 1. I was just trying to cue you on where to go. Did I do that anywhere else? Remember, if it asks you for an equation, it wants it in point-slope form to the best of your ability. On 15, it wasn't crazy easy to do. Okay, anybody got any questions?
No.
Okay, cool. Let me look up your previous question there real quick. Okay. But yes, Franklin, we're moving to 2 full days to complete your assignment. I know that I gave it to them yesterday because there was no reason not to give it to them yesterday. But today is the day that is assigned, so you have 2 days. Okay, also my cross-country boys. I'll take your stuff until the end of the day since y'all were out yesterday.